So Venus and Earth are so different that a foolish question like, what's longer, a day or a year, that makes absolutely no sense on Earth, totally makes sense on Venus. A day on Venus is indeed longer than a year. If we put it into Earth's perspective, a day on Venus would equal 243 Earth days, while a year would only last 225 days. So it's like your birthday is every day. Venus is often nicknamed Earth's evil twin. Their differences are so stark you'd think they're from different galaxies altogether. Just to give you an idea of how far apart they are, if the day-to-year ratio wasn't enough, the Earth rises in the west on Venus but sets in the east. These days, one of the very few similarities between these two is their size. But try to imagine a time when Venus and Earth were like peas in a pod, besties since the beginning of the solar system. Venus used to be the life of the party. NASA scientists think Venus might have even hosted a liquid water ocean and surface temperatures that could have welcomed life for up to 2 billion years. But modern-day Venus is a different story. We're talking extreme temperatures and a thick carbon dioxide atmosphere. So, what led to this cosmic makeover? Size, location, and attitude. I mean that the distance from the Sun and internal heat played a huge role in shaping Venus and Earth's destinies. By the way, there used to be 3 siblings that could have hosted life: Venus, Earth, and Mars. Now imagine 3 cupcakes in an oven. Once they were fully baked, they were taken out of the oven. One of them was put in front of an open window in the middle of winter. Another was carefully placed on a table and covered with a nice clean kitchen towel. And the last one was accidentally forgotten and left in the oven. Oops. Mars, Earth, and Venus are like those cupcakes. Mars got too cold and not welcoming. Earth is still nice and warm and well protected from all the unpleasant things, just like the towel protects that lucky cupcake. And Venus got scorching hot and impossible to consume. In terms of development, Earth took the slow and steady route, maintaining its oceans, stable atmosphere, and biodiversity. Venus, on the other hand, cranked up the temperature, evaporated its oceans, and went all in with greenhouse gases. As a result, we have a planet where you'll melt faster than a snowman in July. Mars, on the contrary, will turn you into an ice popsicle within seconds. But chances are, it might have been pretty hospitable at some point. Some scientists believe that Mars used to be covered with flowing rivers and lakes and had no water shortages. Even today, Mars still has an ocean called Oceanus Borealis, or rather, the remains of what once used to be an ocean. It lost nearly all its water over time. Now, the sources of water on Mars include polar ice caps and minerals and rocks. According to estimates, only 1% of all that water evaporated, while 99% is still locked in the red planet. Ice polar caps are pretty simple to understand, as we have the same thing on Earth. But rocks containing water? Simple. There are at least 4 types of hydrous minerals on Mars. There are hydrous clays made of silicon oxygen, and the cool thing about them is that they can even contain magnesium and iron, which are sulfur-based hydrous sulfates. Now, don't you? I know you thought of the smell of rotten eggs. But it's typical of hydrogen sulfur and not just sulfur. These minerals have water incorporated right into their chemical formulas. There's also hydrous silica, which has water locked in its formula too. Scientists have experimented with growing plants using Martian-like conditions and found success with alfalfa. Harvesting alfalfa also helped improve the growth of other crops like turnips and lettuce. While water may be available on the red planet, the air on Mars is mostly carbon dioxide. On the bright side, and the Mars Oxygen In Situ Resource Utilization Experiment, the Mars Oxy can produce oxygen on Mars, which could be crucial for future missions. As for energy sources on Mars, solar, wind, and geothermal energy are a few promising options. Solar power is less effective on Mars due to weaker sunlight and dust storms. But wind power and geothermal energy could serve as reliable alternatives. With these sources in place, humans could potentially sustain life on Mars. But let's get back to comparing our sibling planets. While both Mars and Earth have moons, and Mars even has 2 of them, Venus has 0, just like Mercury. Due to its proximity to the Sun and the star's gravitational pull, Mercury lacks the ability to retain its own moon. The likelihood of any moon orbiting Mercury either colliding with the planet or being drawn into the orbit of the Sun is high. That's all clear and understandable. But the absence of moons around Venus remains an unsolved puzzle for scientists. Despite Venus's scorching hot temperatures, scientists think that even today it might not be as hostile to life as we once thought. A recent MIT study found 19 amino acids surviving in a Venus-like solution for the whole month. Yep, some like it hot. Also, Rocket Lab and the Massachusetts Institute of Technology are teaming up to send an uncrewed spacecraft, Venus Life Finder, on a mission to Venus. This spacecraft will search for signs of life in the Venusian atmosphere using a special instrument called an autofluorescing nephelometer. And no, I didn't make that up. Originally set to launch in 2023, the mission is now pushed back to December 2024 with arrival at Venus in May 2025. The goal of the mission is to discover organic compounds in Venus's atmosphere, which could point to the possibility of habitable conditions in the cloud layer. The spacecraft is designed with a Photon Explorer cruise stage and a compact atmospheric probe equipped with that nephelometer thingy. The small probe will descend through the Venusian atmosphere, collecting data on cloud particles and organic compounds. In 2020, scientists made a big announcement about finding phosphine on Venus, a compound that could be linked to life. While they're still working on confirming this, using information from telescopes or even past missions, there might be evidence hidden in old NASA data received from Venus that could shed more light on the discovery. The potential presence of phosphine on Venus has stirred excitement and caution among scientists. To make sure, they need more data from telescopes or new space missions. If they find this gas, it might mean there is some form of life producing it in the planet's clouds. This discovery would be a huge step toward understanding Venus better. Some experts think that sending probes to Venus to directly detect phosphine would be the most effective way to confirm its presence. An 80s NASA mission may have already detected phosphine, but scientists back then didn't realize it. Now, this data is being re-evaluated to uncover any overlooked evidence of the presence of the gas. This could also suggest that the compound has been in Venus's atmosphere for decades, raising questions about its source. But not everyone is convinced of this interpretation, which evokes a debate among scientists about the true nature of the detected gases. Old data from other missions may also hold clues about phosphate on Venus. While new spacecraft are going to explore the planet, it's possible that the key to unlocking this mystery lies in decades-old mission records. In total, there have been 46 space missions to Venus, including some flybys where gravity lent a helping hand. The last time we successfully landed a spacecraft on Venus was way back in June 1985 as part of the Vega 2 mission. So, let's see what Venus Life Finder will discover. Earth. The third rock from the Sun. The blue planet. You get it. Its atmosphere is made up of around 78% nitrogen, 21% oxygen, and 1% argon, water vapor, and carbon dioxide. A nice balance for any living creatures to breathe. The weather here is also perfect for life to exist, unlike places like Saturn, Mercury, or any other celestial object in our solar system. We have the troposphere to thank for that. It's the densest part of the atmosphere on our planet and is 5 to 9 miles wide. It's the layer of the atmosphere that always affects our weather and secures the right conditions for life to exist and to have bodies of water. Earth is just sitting in its orbital path, minding its own business, revolving around the Sun until, BAM! Venus and Mars swoop in and spoil the fun. No one wants to leave poor Earth alone. These two relatively large celestial objects moving toward Earth will have dire consequences for our planet, starting with changes in its orbiting trajectory path. The planet's orbits in the solar system have to maintain the right balance so that nothing goes haywire. Of course, if any large object approaches Earth, it would throw our orbiting path off course. The planets will revolve around each other, which will cause plenty of natural disasters on our lands. This will also affect our rotation timing, potentially slowing it down. Days will not flow but drag by. Animals that rely on daytime will need to readjust their biological clocks. Nocturnal animals will also need to figure out how to cope with the long nights. Humans have adjusted pretty well to the 24 hours a day timing. Time itself is just a human construct to measure things. We'll have a tough time sleeping and adjusting to the stretched day. Marine animals rely on the natural current flow to migrate around the oceans. With Mars and Venus crashing the party, it looks like they will also need to find new paths. Birds migrating to other lands throughout the year will also be confused and not know what to do. In general, the Earth's temperature will rise, and massive heat waves and permanent climate changes will occur. This brings us to our next issue, the heat. The radical temperature rise will turn everything into a barren desert. It'll be summer all year long, especially if Venus is in the picture. Most of the planet will dry up and won't be suitable for growing crops. Venus is hot, really hot. Even though it's not the closest planet to the Sun, it's still the hottest. The temperatures on Venus are close to 900 degrees Fahrenheit, which will melt you like an ice cube. The lands on Venus are generally flat, probably due to the temperatures. It's mainly hot because its atmosphere is thick and traps the hazardous gases inside. If Venus inches its way towards us, it'll invite those gases to our atmosphere and compromise it. Mars, or the red planet as we know it, is very cold. That might stay the same if it starts rotating around us. It's also home to the largest dormant volcano in our solar system, which makes Mount Everest look like a tiny bush compared to a tree. With so much instability, it might just wake up one day and spew out molten lava. Mars has a very thin atmosphere, which makes the planet chilly. Its gravity is quite similar to ours. It's actually very cold and has ice caps in the poles covered with carbon dioxide. The same's true for Mercury. You can only last there as long as you can hold your breath and be in the sweet spot between the sunrise and sunset. The three planets orbiting each other will eventually collide. It's just a matter of time. And the Moon, just hanging out like a fly on the wall, will be so insignificant that something will eventually throw it off course and another planet will capture it to its orbit. Or, in the most dire case, it will collide with one of the two intruding planets. Earth will experience extreme tidal waves like nothing before. The two new planets revolving around Earth will cause a major imbalance, making our gravity shift out of control. Each tidal wave will be bigger than the previous one and will cover the dry land. Plenty of little scattered islands in the oceans will be completely submerged. Coastal cities and towns will also be home to fish. Flat countries in general will need boats to get around. Dams and dikes won't be enough to stop the water from coming in. Everyone needs to move towards higher ground to escape the floods. With the climate getting hotter, the polar caps will melt like ice cream on a sweltering summer day and add to the water level rising. Within a few months, the whole Arctic will be nothing but liquid. But wait, there's more! The crust will wear out due to the instability of the Earth's surface and fluctuating gravity. The Earth's crust is mainly made up of oxygen, which means we're basically walking on air. We might experience more earthquakes than before, and dormant volcanoes will wake up from their deep slumber. The skies will be covered in ash, making flights impossible. No one can travel by sea or by air. Importing and exporting will become history. The overall climate will get hotter, just like in Venus. The three planets orbiting each other and their huge mass might even unintentionally welcome other planets and celestial bodies to join the party. So, what if Jupiter decided to turn up? Now, Jupiter is the largest planet in our solar system. To give you an idea, the Earth would be just the size of a grape if Jupiter were the size of a basketball. It also has the largest storm we can perceive. That's known as the red spot, a place twice the size of Earth that has hurricane-like storms that have been going on for hundreds of years. Now, by the time you're done watching this video, you can expect the storm to still be going at it. Since the planet is huge, gravity must be quite strong here. It also has many moons, some of them of our little Earth. There will be no room for any proper space among the planets. Jupiter's moons will be thrown off course and latch onto other planets around. Some of the moons might collide with each other, causing massive debris to be displaced all over the place. The gravity of the planetary party will attract comets to enter the atmosphere, potentially crashing down on us. Oxygen levels will deplete, so the Earth's crust crumbling will continue. It'll rip open the ozone layer, causing heavy strokes of ultraviolet waves to enter our atmosphere. We won't be able to step outside for too long without some protective gear and oxygen tanks. Human civilization will change drastically. We'll all live in sheltered containers that will provide clean air and safe and filtered sun rays. The shelters will be sturdy enough to withstand frequent earthquakes. We will grow only enough crops to sustain ourselves until we leave the Earth. Since it'll only be a matter of time before the planets collide, the next step would be to create large rocket ships to fly us out of the Earth. With Mars, Venus, and Jupiter revolving close to us, it won't be easy to do so. All the space debris will be blocking us from exiting the space zone area. The only safe place outside this region will be many millions of miles away, where only single planets exist. They may or may not have the conditions to host life, but humans will have the technology to land just about anywhere with similar gravity and construct the right shelters. Eventually, Mars, Venus, Earth, and Jupiter will collide with each other and break like eggs, like a big space omelet. Don't forget the moon's crashing and breaking in the mix, but we'll already be far, far away by then, hopefully.
Venus is often called Earth's evil twin. The thing is, this world once started off quite similar to our home planet. But later, something went wrong. These days, the two planets are relatively close and similar in size. But Venus's atmosphere is very different from that on our planet, all thanks to a runaway greenhouse effect that has been going on for a long, long time. The surface of Venus can get even hotter than the surface of Mercury, 864 degrees F. And the surface pressure feels as if you're more than half a mile underwater. The thick atmosphere presents its own challenges. Its clouds consist of sulfuric acid, which is used in lead-acid batteries, as well as industrial cleaners. And if you decided to land on the planet, you'd have to survive atmospheric entry, with friction heating you up to 20,000 degrees F. Still, people have always wanted to explore this inhospitable world. And we can't but talk about the Venera program. During the 1970s and 1980s, several spacecraft studied Venus from orbit and from its hostile surface for an hour or so at a time. The 10 successful Venera landers provided us with most of the data we have today about the surface of this mysterious planet, including surface composition, direct measurements of atmospheric conditions, and sets of unique images. At the same time, astronomers got their hands on these treasures only after a series of annoying failures. They started with Venera 1, launched in February 1961. Each consequent spacecraft was somehow improved and upgraded, but it still wasn't until the fifth group of Venus-bound space probes launched in 1967 that one of them, Venera 4, reached its target and sent data from Venus. Before that, Venera 2 and 3, launched in November 1965, were supposed to land on Venus, but both of them failed in transit. 11-foot-tall Venera 4 was a hefty thing. Its bottom lander was a bunch of instruments and a battery wrapped up in a pressure shell equipped with a parachute. This probe reached Venus in October 1967 and successfully launched the lander. The mother spaceship sent the probe flying over the planet, and it entered Venus's atmosphere. Temperatures were reaching 20,000 degrees F, and the entry force was as great as 450 G. It didn't prevent the onboard instruments from analyzing the atmosphere and sending back data. The first recorded temperature was 102 degrees F, and atmospheric pressure was similar to that on Earth. But the deeper the probe went, the higher the numbers became. 10 atmospheres, 20. They kept going up much higher than engineers had anticipated. 93 minutes into the mission, when the probe was still more than 16 miles above the surface of the planet, Venera 4 cracked open near its top and crashed. At the crash point, the measurements showed 22 atmospheres and 530 degrees F. Scientists realized that they needed a bigger spaceship. After some intense engineering, Venera 5 and Venera 6 saw the light of the day. Engineers did everything they could to make the landing probe stronger, but they were pressed for time. That's why Venera 5 and 6 were not fully prepared when they went on a mission. That's why Venera 5 transmitted data for a mere 53 minutes before succumbing to temperatures of 600 degrees F and pressures of 27 atmospheres. And Venera 6 lasted for 51 minutes. In any case now, the leaders of the project knew what it would take. 840 degrees F, 100 atmospheres, corrosive acids. They seemed to be prepared. They found new materials to build the probe. They got a hotter and stronger test chamber for the trials. They modified the parachute to make the lander fall faster so that the probe could spend as much time on the surface as possible. The lander was also designed in the shape of an egg and made of titanium, so its surface was smooth and had just a few ports, welds, and substructures. The insides were lined with a shock absorber and insulation layer. The chamber was also to pre-chill to freezing temperatures before entry. And Venera 7 was finally a success. It reached the planet in December 1970, separated from the mothership, and went down into the atmosphere. The probe transmitted data for 35 minutes, and things seemed smooth. But then, its chute melted, and the probe dropped like a rock, hitting the ground at 35 miles per hour and bouncing. Then, a second after the landing, the signal was abruptly cut. It looked like the probe crashed to bits. Shockingly, a few months later, while looking through all the data they managed to get, engineers rediscovered the signal. It was super weak and lost amidst the noise. Apparently, when Venera 7 bounced, it misaligned the antenna. The probe rested on its side, which weakened the signal to 1 or 3% of its initial strength. The probe kept transmitting data for 23 minutes. After that, the temperatures got too high and melted its shell. Venera 8, launched in 1972, had a similar design and experienced a similar fate. Venera 9 and 10 were a new generation of probes. They could send back black and white photos. It was actually the probe's main goal, to send the first ever photographic panorama from another planet. Venera 9 and 10 were 5 times heavier than their predecessors and weighed 5 tons at launch. The lander was 6.5 feet tall. It was basically a hermetically sealed titanium sphere that was supposed to hold the instruments. It was bolted with gold wire seals. Inside, there were shelves of beryllium and electric fans, whose main goal was to disperse heat to prevent instrument failure. On the bottom of the lander, there was a shock-absorbing ring. And at the top, there was a titanium ring that looked like a hat. It served as an aero brake. The parachute was supposed to detach at 30 miles above the surface, and the aero brake had to do the rest. In October 1975, Venera 9 and 10 arrived at Venus and landed as planned. Venera 9 was the first to land. It touched down on a slight slope, a volcanic crater or a hill, and kicked quite a bit of dust while landing. One of its 2 cameras succeeded in photographing and transmitting data, and soon scientists saw the first ever pictures of the surface of Venus. It was mostly sharp rocks, soil, and a distant horizon. The sun was slightly obscured by clouds that day. A gentle breeze was blowing. Overall, it was a pleasant morning. If you didn't pay attention to crushing pressure, almost completely waterless atmosphere, insanely high temperatures, and corrosive acids. Venera 10 landed in the same way a few days later, but the terrain it landed on was much more boring. Just a rolling plain with hardened pieces of magma. Both probes transmitted for 40 to 60 minutes until their orbiters went out of range. When it happened, the temperatures inside the probes were reaching 140 degrees F. The orbiters later burned up in the atmosphere after completing their mission. Venera 11 and 12 could have been a success, but a mysterious electric anomaly messed up with their cameras, so their trip was quickly forgotten. And Venera 13 and 14 entered the picture. They had improved scientific instruments and cameras that could take color images, and new heat-resistant technologies were used during the creation of these probes. Venera 13 arrived first and landed as planned. It took 2 photos, one black and white and the other in color. In the photos, one could see a surface of pebbled, loose soil and outcroppings of bedrock. It all looked pretty similar to the surface of the ocean. In the distance, there were rolling plateaus and an orange sky. The images taken later by Venera 14 showed a more weathered plain with less loose soil and fine-grained rocks. The 2 probes also sent back what they heard. It mostly sounded like a gently blowing wind with hints of distant rumbling. Could be Venus quakes. Venera 13 and 14 were the last landers to touch the surface of the planet. Venera 15 and 16 just flew around Venus, mapping its topography from orbit.
Hey there! Imagine a place on Earth that's just like Venus. It's Chile's Atacama Desert. I assume you wouldn't want to spend your holidays there. Similar to other deserts, this one isn't exactly the friendliest place. It's a long stretch of land close to the Andes Mountains. This makes it one of the driest spots on the planet. In fact, it's so dry that only a few places in Antarctica have stayed without rain for longer. This tough environment has some benefits to offer. Because it's located high up and doesn't have many clouds or a lot of light pollution, it's become the perfect home for advanced telescopes. These telescopes help us explore the cosmos. A new study from June 2023 revealed that this desert is even weirder and more out of this world than we had thought. It makes sense that a desert as dry as this one gets a lot of sun. On average, it has about 308 watts of sunlight per 10 square feet. That's almost twice as much as places like Europe or the eastern United States get. Raul Cordero is a scientist. He and his team checked out the sunlight in the spot housing the biggest telescope project ever, the Atacama Large Millimeter Array. And this is the sunniest place on Earth. This is what you'd experience if you were about 79% of the way from the sun to Earth. Of course, if you were actually on Venus, you would have way bigger things to worry about than just a lot of sunlight. Now let's figure out why this place is almost as sunny as Venus. It's because of clouds. Usually, clouds block sunlight and keep us cool, but sometimes they can act like a magnifying glass in special situations, concentrating the sun's rays. This is called forward scattering. This happens when certain types of clouds show up during the South American monsoon in the middle of the summer. During the summer in the southern hemisphere, we're actually a bit closer to the sun, and there's less ozone in that part of the world. This combo might explain why other high places on Earth, like the Himalayas, don't get as much intense sunlight as this desert. Let's talk more about Venus. What would it be like to stand on the surface of this planet? The more you learn about this sweltering world, the less you want to picture yourself there. It's not a friendly place at all, with crazy heat and super heavy air that could crush you. But pretend for a moment that you're on Venus. The air there is thick and heavy, 93 times denser than what we have on Earth. The air presses you down. Think of having a small car resting on your thumbnail. That's how it would feel. Or think about diving really deep into the ocean. You'd feel a lot of pressure pushing on your body. But on Venus, it's like having all the pressure of the atmosphere squishing and almost flattening you. What is the weather like on Venus? Ouch! Heat. Even though Mercury is closer to the sun, Venus wins the prize for the hottest planet's surface. That thick air on Venus is mostly carbon dioxide, which acts like a blanket. When the sun shines on Venus, the heat gets trapped by this blanket of air, and the planet heats a lot. Temperatures on Venus can hit 860 degrees Fahrenheit. Now, how do we explore Venus without getting roasted or squished? Well, going there in person is a no-go. Robots can handle it, yet even robots have struggled on Venus. Only a handful have made it to the surface. and they only managed to survive for a few hours before getting wrecked by the harsh conditions. The good news is we're figuring out ways to study Venus without putting anyone at risk. Future missions will check Venus out from above. Spacecraft up there will be able to see through the atmosphere without any trouble. NASA's got the Veritas mission. Its aim is to make detailed maps of Venus from orbit, giving us a new view of the place. So we've examined the driest desert on our planet, the Atacama Desert. No wonder this area is the place that serves as testing grounds for space missions. But despite how arid this region is, there is life there. This is a realm of flamingos and lagoons. The place has colossal salt flats that extend for 4,633 square miles at a depth of 82 feet. It's a place of erupting geysers, naturally heated springs, towering volcanoes, herds of llamas, and deserts so parched that certain pockets have remained untouched by rain for over half a millennium. All this unfolds 2 to 3 miles above the sea level. What else survives in the Atacama Desert? It's quite hard to fathom that plants could thrive in such inhospitable conditions. Yet, they managed to survive here. Take, for instance, Tillandsia landbecki. These plants defy the odds in the desert by extracting moisture from the fog that rolls in from the nearby coast. This fog water can also serve as a sustainable water source for humans. These plants lack traditional roots. Instead, they use their older, deceased parts to anchor themselves in the sand, forming little dune-like structures. They draw moisture out of the mist through their slender leaves and shoots, which swell upon contact with water. Nocturnal dew also provides water, particularly during the summer when fog is scarce. Together, plant communities existing there are known as lomas vegetation. The presence of this vegetation in the Atacama Desert is limited to a narrow coastal area where fog regularly occurs. Factors such as the distance from the Pacific, prevailing wind direction, and topography restrict the distribution of fog ecosystems. Satellite data analysis reveals that plants grow at altitudes ranging from 2,625 feet to 4,100 feet above sea level and up to 28 miles inland. They are mainly found on sandy plains along fog corridors or on slopes. They're about as tall as 1.5 feet, and they usually form a line. This clever lineup helps them catch all the moisture and yummy nutrients they need. The arrangement of these clusters depends on how much foggy water they can find. These tough desert plants are like water wizards of the plant world. They're so good at surviving in the desert that they give us ideas about getting water from fog. Water is precious in places like Iquique and small villages near the desert. Plus, with all the digging for stuff like copper and lithium, which makes batteries work, they need even more water. Usually, people get drinking water from under the ground, but these little plants have something to teach us. Using this trick, we're making a map showing where these plants like to party most. This map could help us find perfect spots for catching fog with special nets. Here's another idea that will make you feel like you're on the surface of another planet. Pelican Point is in Namibia. You might not expect it, but Pelican Point is actually a great place to surf. Every year, it only gets around 0.30 inches of rain, but that doesn't stop surfers from riding the waves. The weather is kind of unique here. It's hardly ever too hot or too cold. This place has an unusual type of dry climate, thanks to the cold ocean currents near the bay. Skeleton Bay, alternatively named Donkey Bay, is an iconic surfing location. The surf wave crashes onto the sands of Pelican Point, situated about 5 miles northwest of Walvis Bay, a compact harbor town famous for its sand dunes and secure anchorage. Would you surf there?
Venus is often called Earth's sister planet. For one thing, these two are almost the same size. Plus, Venus and Earth are very similar in mass and composition. Venus orbits the Sun within its Goldilocks, aka habitable, zone 2, just like Earth. But the differences between our home planet and Venus are more substantial than any similarities. For example, the atmosphere of Venus is 90 times as thick as what we have here on Earth. The surface temperature is so high you could melt lead there. And the air is toxic. It consists of carbon dioxide and sulfuric acid. In other words, if humans decided to move to Venus, some serious terraforming, which is basically ecological engineering, would be needed first. And still, some scientists believe that Venus is an even better candidate for terraforming than Mars. And there are several suggestions on how to do it. One of the ideas involves the use of genetically engineered algae to fix carbon into organic compounds. Unfortunately, the more researchers study this method, the less plausible it becomes. The main problem is that the production of organic molecules from carbon dioxide needs hydrogen. But this element is extremely rare on Venus. This planet doesn't have a protective magnetosphere, and its upper atmosphere is exposed to direct erosion by the solar wind. That's why it has lost most of its original hydrogen to space. Also, any carbon that was bound up in organic molecules would be converted back into carbon dioxide in no time due to the ultra-hot surface environment. And Venus wouldn't even begin to cool down until after the removal of the largest part of carbon dioxide. The next idea was to bombard Venus's atmosphere with hydrogen. As a result, water and graphite would be produced. This water would fall down to the planet and cover almost 80% of its surface, forming vast oceans. To do it, we would need loads of hydrogen, so it would have to be harvested directly from one of our solar system's ice giants or their moons. This suggestion also involves iron aerosol getting added to the atmosphere of Venus. It could be derived from a number of sources, like the moon, asteroids, or Mercury. The resulting atmosphere would be around 3 bars, which is basically 3 times more surface pressure than on Earth. It would also mainly consist of nitrogen. With time, some of it would dissolve into new oceans, reducing atmospheric pressure even more. There's also an idea of solar shades. A series of small spacecraft or a single large lens might be used to divert sunlight from the planet's surface. This could probably reduce the insane temperatures on the planet. Venus absorbs twice as much sunlight as our planet. It's believed to have played a big role in the runaway greenhouse effect, which has made the planet what it is today. Such a shade could be based in space. This way, it would also serve to block the solar wind, thus reducing the amount of radiation the surface of Venus is exposed to. This radiation is a huge issue when it comes to the habitability of the planet. If this method indeed managed to cool Venus down, it would lead to atmospheric CO2, becoming liquid or frozen and getting deposited on the surface as dry ice. Solar reflectors could also be positioned in the atmosphere or on the surface of the planet. In this case, they could be large, reflective balloons, sheets of carbon nanotubes or graphene, or something totally different. One of the coolest suggestions is to build cities above Venus's clouds. This way, they could act as both solar shields and as processing stations. The first colonists would live there, acting as terraformers, gradually converting the atmosphere of the planet into something livable. Later, they would migrate to the surface.
What if I told you that humans could have evolved on a planet other than Earth? And we're not talking about Mars here. This planet is Venus, one of the most toxic and dangerous places in our solar system. But imagine this. Once upon a time, Venus was a happening place for potential life. And maybe, just maybe, life was there. How is that possible? And what happened? Let's figure it out. Picture this, a planet swathed in clouds and named after a deity of love and beauty, Aphrodite. Sounds enchanting, right? But don't be fooled. Venus, our neighbor, is the second planet from the sun, and it's no picnic. Its surface is hot enough to melt lead, and the atmosphere is so thick that the sun is just a blurry smudge. As you get closer to it, things turn from dreamy to downright hellish. about 30 miles up in the atmosphere, temperatures range from 86 to 158 degrees Fahrenheit. And this is just the beginning. To survive on Venus, you'd need super-duper insulation, because temperatures can reach a sizzling 900 degrees Fahrenheit. Plus, the weight of the atmosphere would bear down on you like being submerged deep in the ocean. The atmosphere is mostly made of carbon dioxide, and down at the surface, it behaves in a corrosive way due to the intense heat and pressure. The sky is sulfur yellow, and the clouds are composed of sulfuric acid. The surface is filled with active volcanoes and craters. Yikes! It's like the environment itself turns against you. Venus is often referred to as the Earth's twin. That's because Venus is almost as big as Earth, just a tad smaller, and these two planets look quite similar on the inside. But in reality, Venus is more like Earth's opposite than its twin. It spins in the opposite direction, has longer days than years, and has no seasons to speak of, not even mentioning its crazy weather conditions. But believe it or not, it wasn't always this way. A long time ago, around 3 billion years after it was born, Venus might have been a watery wonderland like our beloved Earth. It had a cozy climate, and researchers think there was even enough time for life to emerge. But how do we know that? Back in 1978, NASA's Pioneer Venus spacecraft discovered hints that Venus might have had oceans on its surface. Since then, scientists have sent more missions to explore the planet, and they've learned some fascinating things about its past. NASA researchers have come up with 5 cool simulations to show what Venus was like with different amounts of water covering its surface. To create these simulations, scientists used a fancy 3D model that takes into account the gases in Venus's atmosphere billions of years ago and how they are now. They also considered how the sun's radiation has changed over time, getting warmer as it ages. And it turns out that Venus used to be a lot like Earth. All simulations suggest that Venus could have had stable temperatures, ranging from a comfy 68 degrees Fahrenheit to a toasty 122 degrees Fahrenheit. In some of the simulations, Venus had a similar landscape to what it has now, with a shallow ocean and some water trapped in the soil. In others, they imagined Venus having a deep ocean or even the entire surface covered in water. Surprisingly, in all these scenarios, Venus could have maintained temperatures suitable for liquid water. Now, imagine a parallel universe where Venus stayed this way. What if things turned out differently and it was still as cozy as Earth? It could have been the perfect place for humans. Its oceans would have provided a nurturing environment for life to flourish and evolve. The temperatures would have been like a perpetual springtime picnic. Can you imagine lounging under a Venusian palm tree, sipping Venusian lemonade? Ah, the good life. Also, Venus had a slow rotation compared to Earth. Days would have stretched out, giving us more time to enjoy life's simple pleasures. Instead of 24 hours, a Venusian day might have lasted for months. You could have taken an extended vacation and still had time for a full makeover. And what about the higher atmospheric pressure? It may sound intimidating, but it could have actually worked in our favor. The higher pressure would have provided a cozy and snug environment, like being wrapped in a warm, fluffy blanket. No need to worry about the chilly winds of other planets. Venus would have had us covered. Oh, and remember the acidic atmosphere? It may sound strange, but it would have had its benefits too. Venus would have been a carbon dioxide-loving paradise. Plant life would have thrived, creating lush landscapes and filling the air with fresh oxygen. So in this scenario, Venus could have been our haven among the stars. So what happened? What has ruined Venus? Unfortunately, everything changed about 700 million years ago. There was a huge event that caused Venus to change completely, turning it into the hostile place it is today. It experienced a runaway greenhouse effect, which made its atmosphere super thick and scorching hot. A runaway greenhouse effect sucked all the water into space, leaving behind a scorching surface of volcanic rock with thick, crushing atmosphere and acid clouds. Yikes. So what caused this catastrophic transformation? Well, our experts believe it may have been due to volcanic activity. When magma and molten rock reached the surface, they released a bunch of carbon dioxide into the atmosphere. If the magma cooled before reaching the surface, it created a barrier that prevented the gas from being reabsorbed. Massive amounts of gas were released into the atmosphere. Something similar happened on Earth with the Siberian traps, which caused a mass extinction. Venus had its own mega transformation. So, unfortunately, this catastrophe changed the history of our solar system once and forever. But here's the fascinating part. This little mysterious planet still could teach us a lot about the origins of life. For example, if Venus was once habitable, it opens up exciting possibilities for exoplanets in the Venus zone of other star systems. Maybe they could support life too. There's also a critical question that scientists ponder. How do these life-friendly worlds come into existence? Early on, Venus and Earth were strikingly similar. They were close in size, had similar structures inside, and even had oceans in their youthful days. But one planet turned into a scorching inferno, while the other became a thriving hub for abundant life. Why is that? And finally, believe it or not, we can't completely rule out the possibility of life on Venus even now. Up high in the thick yellow clouds where the temperature, air pressure, and chemistry are friendlier, there might be a chance. That's a range where earthly life, like tough extremophile microbes, could potentially survive. The atmospheric pressure up there is similar to what we experience on Earth's surface. We've even noticed strange dark patches in its atmosphere that come and go. Dark streaks persist, defying hurricane-force winds and absorbing ultraviolet radiation. Scientists are scratching their heads over these persistent streaks. They suspect they could be made of fine particles or ice crystals. But here's where it gets wild. Astrobiologists consider another option. Could these streaks be made up of Venus-style microbial life? They theorize that ring-shaped sulfur compounds in Venus's atmosphere could act as a protective coating for the microbes. Wouldn't that be amazing? That's why, by studying why Venus went down a different path in terms of habitability, we can unlock the secrets of what makes other worlds just right for life. However, there are still mysteries to solve. We need more missions to study Venus and understand its history better. For example, learn how quickly it cooled down after its formation. We also want to figure out if the transformation was a one-time cataclysm or a series of events over billions of years. Nonetheless, we can still dream of the Venus that could have been. A paradise where humans and Venusians could have lived side by side. So keep your eyes on Venus. It's a wild planet with a captivating history. Who knows what other surprises it has in store for us? Let's keep exploring and reaching for the stars.
In 2020, scientists studied Venus's surface. This planet has a similar atmosphere to Earth. That's why it's so interesting to people. During studies, they discovered there's phosphine in the surrounding gases of this planet. This substance has organic compounds, phosphorus, with carbon or hydrogen combination. This was an important discovery because the colorless, poisonous phosphine may have a biological origin. On Venus, the recent volcanic activity can be a reason for the appearance of this gas. But it's also possible that some bacteria really live there. Now let's move from Venus to Earth to the Falkland Islands. Beautiful Gentoo penguins live here. Scientists took samples of the penguins' excretion for studying. In the lab, they analyzed the Gentoo's doo-doo and found phosphine there. This discovery shocked everyone. How did the substance that exists 38 million miles away from us got inside penguins? It's hard to believe, but what if these unusual birds came to us from Venus? Maybe they often raise their heads up to see their faraway home in the starry sky. Penguins are rare birds that can turn saltwater into freshwater inside their body. There are unique glands next to their eyes that work as powerful kidneys. It allows penguins to remove salt from the bloodstream. So maybe this same gland can help them survive on Venus in some way. Penguins can't fly only on our planet. But just imagine Venus's atmosphere is perfect for flights. It's possible that millions of penguins are flying on Venus right now. We just can't see them because of the gases covering this planet. Of course, it's unlikely that this theory will find confirmation. Penguins would hardly be able to survive in Venus's atmosphere, which is 96% composed of carbon dioxide. There's also a small amount of sulfuric acid clouds on this planet. But scientists still don't know how the bodies of these birds can produce phosphine. They plan to conduct a thorough study and observe the behavior of Gentoo penguins. They need to know what the birds eat, what kind of lifestyle they lead, and much more. After the study, scientists hope the penguin phosphine will help identify many different organisms living on other planets. It's possible that inside the penguins, certain anaerobic bacteria produce phosphine to fight other competing microbes. Traces of phosphine can also be found in pond slime on our planet. In the future, scientists are going to send several probes to Venus to explore the planet's atmosphere and find the source of phosphate. There's another animal that may be from another planet. No, not me. This time, it lives in seas and oceans. In 2018, a scientific article was published where a group of researchers stated octopuses were not born on Earth. And this is not a metaphor. They literally called them creatures from outer space. And in fact, there are several reasons to think so. One of the hypotheses says that viruses from other worlds fell into the Earth's ocean and infected squid with shellfish, and forced them to evolve into octopuses. Another theory says the octopus's eggs were brought to our planet on a meteorite. All these versions appeared because of how unique the octopus is. These sea creatures are closely related to snails, mollusks, and squids. But octopuses are much smarter. They are the smartest invertebrates on the planet. Their intellectual abilities are also superior to many mammals, including some guys I went to school with. They have one of the most complex nervous systems of all living organisms. Octopuses have a central brain in their body, and their tentacles are endowed with a neural connection that allows them to think separately from the central mind. Their vision is developed in such a way that their eyes can be compared to the lens of an expensive video camera. They can change color and shape, disguise themselves with a combination of color pigment, nerves, and muscles. But the coolest thing is their intelligence. They can relax and do nothing, be lazy, and have fun. No other creature on the planet has such an unusual appearance and behavior. But the main reason to consider them as aliens from outer space is their history of evolution. In any existing animal, you can track its evolutionary stages of development. For example, elephants and mammoths descended from a common ancestor from the elephant family that went extinct 5 to 6 million years ago. If you look even further, you see almost all mammals descended from animal-like reptiles. Almost every animal has a branch of evolution that has made it what it is. Each species changes over millions of years. But octopuses don't have this branch. They suddenly appeared on the family tree. From the point of view of evolution, squid should evolve into octopuses in millions of years. But scientists can't track the evolution of octopuses with all their intelligence, their tentacles, and their ability to disguise themselves. The octopus genome is unlike any other genome on the planet. If the outer space origin of octopuses turns out to be real, it could confirm the theory opposite to Darwin's evolution. According to this theory, living organisms or their embryos were brought to Earth from outside on meteorites. But for now, there's no evidence to support this theory. Some scientists believe that octopuses separated from the squid line about 135 million years ago. But this theory hasn't been proven either. But if octopuses came to us from outer space, how is it possible that living organisms survived an interstellar voyage? In fact, this is not impossible. There are creatures on Earth that can survive in space, and these are tardigrades or water bears. These are microscopic 8-legged invertebrates close to arthropods. You need a microscope to see them, but even a cheap one will let you see them in detail. From the outside, they look somewhat like bears. They are called water bears because they require a thin layer of water around the body to prevent dehydration. These creatures have been found in all kinds of environments, from the depths of the ocean to hot sand dunes. They are incredibly tenacious thanks to their unique structure. They look soft, but their body is covered with a hard cuticle. This covering resembles the exoskeleton of grasshoppers, mantises, and many other insects. Water bears shed the old cuticle layer to grow. Each of their 8 legs has 4 to 6 claws, which helps them cling to any surface. The tardigrades manage to survive at a temperature of minus 328 degrees Fahrenheit. This is almost 3 times colder than in icy Antarctica. Hot conditions aren't a problem for them either. They have survived a temperature of 300 degrees Fahrenheit. This means they exist in boiling water. Water bears aren't afraid of radiation or high pressure. In the depths of the ocean, pressure can destroy alloys of strong metals. The water bear can withstand pressure 6 times heavier. But the coolest thing is that they can live in the vacuum of space. Our planet has a magnetic field, that is, a shield that protects us from solar radiation. Tardigrades don't care about this radiation. They can go into low Earth orbit and return unharmed. Their body strength is provided by a protein that protects their DNA from ionizing radiation. Tardigrades can also fall into a state of cryptobiosis. If the surrounding conditions suggest freezing, drying out, lack of oxygen, or an overabundance of salt, the tardigrade pulls its head and legs inside the body and falls asleep. It can stay in the form of an unmoving barrel until the conditions around it improve. This state of cryptobiosis allows them to live without water and food for decades. In 2016, scientists managed to revive 2 tardigrades that had been sleeping for more than 30 years. These creatures have survived 5 global catastrophes on Earth. They appeared about 5 billion years ago, and it's possible they'll live just as long. They aren't afraid of any apocalypses. Asteroids hit our planet, a supernova explodes nearby, and its radiation splashes out on Earth. A global heat or ice storm starts. People and most living creatures may not survive these events, but the water bears can.
In our solar system, most planets spin counterclockwise, but not Venus. This rebel planet decided to spin clockwise, and scientists are still trying to figure out why. By the way, why do planets rotate in general? What defines the speed of their rotation? Does the sun rotate? Buckle up and let's try to answer these questions. Venus is the second planet from the sun and the hottest planet in our solar system. Did you know that Venus is sometimes called Earth's twin? That's because it's similar in size and composition to our own planet. But that's where the similarities end, because Venus is a pretty crazy place, to say the least. For example, the weather. On Venus, it's always hot and cloudy. And when I say hot, I mean it like it's over 800 degrees Fahrenheit there. And those clouds, they're not made of water like the ones on Earth. Instead, they're made of sulfuric acid. So yeah, you wouldn't want to go outside without a really good sunscreen on Venus. If you look at the photos taken from its surface, you can see these toxic yellow clouds and cracked, desolate landscapes. And the spacecraft that captured this turned off almost immediately after sending these photos. Poor fella. But the surface of Venus isn't just some solid, dark, flat land. In fact, Venus has mountains that are taller than Mount Everest. These mountains aren't made of rock like the ones on Earth, though. Instead, they're made of a kind of volcanic material that's denser. Venus is a pretty creepy place that holds many mysteries. One of them has been puzzling scientists for years, and this is the planet's rotation. Most planets in our solar system rotate counterclockwise, but Venus isn't like the other girls. It rotates clockwise, and that's not all. It also rotates around the sun faster than it rotates around itself. In other words, a year on this planet passes faster than a day. It's almost like Venus made being quirky its life mission. But why is that? Well, scientists have a few theories. The most popular theory says that Venus was actually spinning counterclockwise like the other planets, but then something happened to flip it around. And what could that something be, you ask? A planet-sized object. Yep, astronomers believe that something huge once collided with Venus, causing it to spin in the opposite direction. You can imagine this like a cosmic billiard shot, with this mysterious huge object being the cue ball and Venus being the target ball. But we can't actually say that Venus is spinning the wrong way. There's no such thing as a wrong direction of spin in the universe. This is actually called the retrograde rotation. This is when a planet rotates in the opposite direction to its orbit around the sun. Venus, for example, has a retrograde rotation, which means that the sun rises in the west and sets in the east on that planet. So now, when the horoscope says something like Mercury in retrograde, you'll know what it means. Oh, but Venus isn't the only weird one in our solar system. There are definitely some wacky ways that planets can rotate. For example, most planets in our solar system spin around an imaginary line called an axis. This axis is usually straight up and down in relation to the planet's orbit around the sun. However, some planets like Uranus have a tilted axis, which means it's almost on its side in relation to its orbit. This tilt causes the planet's poles to be nearly in the same place as its orbit. The result? As the planet orbits the sun, different parts of it receive different amounts of sunlight, causing extreme seasonal variations. For example, one pole might experience continuous sunlight, while the other is in complete darkness for a long time. Uranus is the only planet in our solar system that rotates on its side. Scientists think that it could repeat Venus's history. Once upon a time, a large impact knocked Uranus off its original axis of rotation, causing it to tilt at an angle of 98 degrees. We should be grateful for Jupiter. Its crazy gravity pulls all the asteroids and protects us from such collisions. All this is somewhat similar to tidally locked planets. Imagine going on a date with a planet, but instead of being charming and mysterious like you'd hoped, it's just staring at you with the same face all night long. That's basically what it's like to hang out with a tidally locked planet. Tidally locked planets are planets that rotate around their axis at the same rate that they orbit their star. This means that the same side of the planet always faces the star, while the other side is in permanent darkness. Being tidally locked can have some weird effects on the planet's climate and weather. The side facing the star can become extremely hot, while the other side can be incredibly cold. The atmosphere on the planet can also get pretty wild, with strong winds blowing from the hot side to the cold side. And it doesn't have to be planets only. Our moon also works this way. Did you know that we always see only one side of the moon? That's because it's tidally locked to the Earth. We can also take the dwarf planet Pluto as an example. It has a strange rotational relationship with its largest moon, Charon. They're tidally locked, which means that they always face each other with the same side. As a result, Pluto and Charon appear to waltz around a common center of gravity, creating a unique dance in space. But the oddities of our solar system don't end there. There are also planets with super fast rotations. While most planets rotate at a fairly sedate pace, some of them are sonic levels fast. Jupiter, for example, rotates once every 9 hours and 56 minutes, which means that it has a day that's less than 10 hours long. That's fast enough to cause the planet to bulge out at its equator. And also, this rapid rotation creates strong bands of winds that can reach speeds of up to 400 miles per hour. And if all this still seems logical and kinda makes sense, then how about chaotic rotations? Yep, some planets have a rotation that's so irregular and unpredictable that it's known as chaotic rotation. This is often caused by the gravitational influence of nearby moons or other planets. And it's mostly the case with moons and small objects like that. In our solar system, some moons of Pluto, Saturn, and Neptune have chaotic rotation. By the way, the Sun rotates too, just like the planets. However, its rotation is not uniform. The equator rotates faster than the poles. Pretty weird, isn't it? This phenomenon creates a magnetic field that's responsible for phenomena like sunspots and solar flares. But all this raises an interesting topic. Why do planets rotate in the first place? This may sound like a silly question, but can you answer it? The answer might be trickier than you imagine. It all started around 4.5 billion years ago with the formation of our solar system. When it formed, it started as a large cloud of gas and dust. As the cloud began to contract due to its own gravity, it began to spin faster and faster, like a spinning top. This spinning motion caused the cloud to flatten into a disc-like shape. As the cloud continued to contract, the center became denser and hotter, eventually forming the sun. Meanwhile, the material in the disk began to clump together and form planets. But because the disk was already spinning, this spinning motion was inherited by the planets as they formed. In other words, the planets rotate by inertia. They inherited the spinning motion of the cloud of gas and dust from which they formed. This is known as the conservation of angular momentum. This is the same principle that causes ice skaters to spin faster when they bring their arms in. And that's a wrap on the wacky world of planet rotations. From the lightning-fast spin of Jupiter to the bizarre backwards rotation of Venus, it's clear that our solar system is full of surprises. But thanks to the laws of physics and the gravitational pull of the Sun, these planets continue to spin on, keeping time with the steady beat of the cosmos. Stay tuned.
These days, you're better off boarding a plane if you want to travel from New York to London. But what if I told you there was a time when these two cities were actually on the same continent? Well, the explanation is a bit more complex. For starters, back then, these two cities didn't even exist at all. But the tectonic plates they sit on today were a lot closer. Nearly 200 million years ago, all of the continents on our planet connected, making up one large supercontinent. This enormous piece of land was surrounded by one single ocean. We call this huge continent Pangaea these days. Some parts of this continent broke apart and shifted away from each other for our maps to reach their current configuration. There's even a nice experiment you can conduct to test this theory. Find a map online and print it on a piece of paper. After that, simply cut out all of the continents. Once you start playing around with them, you'll soon notice they all seem to fit together, like pieces from a puzzle. Probably the most striking thing you'll see is how South America perfectly fits Africa. What's even more fascinating is that this isn't the first time in our planet's history that supercontinents have been formed and then broken apart. Scientists have figured out that this happened at least 3 times before. And if we consider our planet's age, 4.5 billion years, the last 200 million is closer to the blink of an eye. So how did scientists figure out that continents move? Apart from the aspect of today's continents, they also looked at identical rocks, which have been found on different continents. They looked like they formed from the same minerals and under the same weather conditions. Some other secret helpers? Well, dinosaurs. Fossils from the same species have been stumbled upon in both South America and Africa. This particular dinosaur, named Mesosaurus, is said to have lived on our planet way before the continents drifted apart. It's hard to imagine how life on Earth must have been with one single continent. For starters, the climate must have been very different. That's because the mid-portion of the land would have probably been bone dry, having little to no source of water. More so, it was most likely hidden away behind many mountain chains. These would have acted as a barrier against moisture and rainfall too. However, geologists have also studied coal deposits from the United States and Europe. These seem to show that at least a part of the ancient supercontinent, which was close to the equator, must have been an amazing tropical rainforest, just like those we can find in the Amazonian jungle today. Coal appears when remnants of plants and animals get stuck into swampy water. If enough pressure is applied by the water, the substance is first turned into peat, then into coal. Our planet existed in this continental configuration for over 100 million years, and during this time, there was a lot of life on Earth already thriving. Hey, it was a great time to be an insect. Critters like beetles and dragonflies flourished. During the same time period, the Earth was roamed by the predecessor of all mammals, the synapsid. Life in Pangaea was severely hit during one not-so-great period. It's believed that a comet or asteroid landed on the surface of the Earth about 251 million years ago. The asteroid or comet theory seems to fit pretty well, because 90% of all marine animals and 70% of the creatures living on land disappeared all of a sudden. The comet might not have been the only reason for the mass extinction. At the same time, there was also some important volcanic activity happening in northern Asia, which might have disrupted life on Earth. We may not notice it, but continents do continue moving as we speak. This configuration we now see with the help of satellite imagery will surely not be the last. Australia, for example, is slowly moving towards Asia. But the most important proof that our continents are still shifting is the eastern portion of Africa. This area is simply breaking off from the rest of the land. To witness this, you'll have to travel to one of the hottest places on our planet. But if you get to this piece of land on the eastern part of the African continent, you might sit on top of the exact spot that, soon enough, will be split in two by water. Underneath this region, 3 tectonic plates are slowly drifting apart. If the data is correct, in the far future, Africa will be split in 2, and between its 2 regions, a new ocean will arise. To support this theory, scientists have been closely studying a 35-mile-long crack in the Ethiopian desert for years. For this new ocean to form, it's estimated that 5 to 10 million years need to pass. Since our planet's crust is made out of multiple tectonic plates that are constantly moving, it's the perfect place to study this process. These plates are all irregularly shaped, and they are always mashing against, sliding under, or over each other. Those 3 tectonic plates found under the desert are also moving at different speeds. One of them, called the Arabian Plate, is sliding away from Africa at a speed of about 1 inch per year. The other 2 plates are moving a bit slower, somewhere between ½ an inch to 0.2 inches each year. More so, as these movements happen, material from deep inside Earth climbs to the surface and forms an oceanic crust at the edges. All this movement does make you wonder, how will the next supercontinent form, and when? So far, scientists came up with some possible configurations, each with its own name: Novo Pangea, Pangea Ultima, or Amasia. All these predictions still vary, as we're not sure how and why continents really move over time. One clue may be actually looking at how Pangea separated in the first place. Regardless, it will take anywhere from 15 to 100 million years to see the next future continent, depending on each scenario. Novo Pangea looks at the possibility in which present-day movements continue. In this scenario, the Atlantic Ocean will continue to expand, all the while making the Pacific smaller. The 2 American continents would first combine northward. Africa, Europe, and Asia will have already combined too, by the time they all meet together in one single huge piece of land. Another possible scenario is called Pangea Ultima. In this case, the Atlantic will slow down in its expansion and actually become a landlocked body of water. North America, Africa, Asia, and Europe would become somewhat parallel pieces of land, completely sewn together. Underneath them, South America, Antarctica, and Australia would complete the circle surrounding the North Atlantic. All the while, this piece of land would be surrounded by a large Pacific Ocean. Amasia looks at a scenario that's a bit difficult to understand and study at this point. Since several tectonic plates look like they are moving north, it might be possible that all continents, apart from Antarctica, will slide completely toward the North Pole. The climate would be a lot different and way colder. Both the Pacific and the Atlantic, in this scenario, would remain open bodies of water. Scientists believe this to be a real possibility because of some anomalies left by Pangea deep in the Earth's interior in the part called the mantle. Looking even further into our planet's future, it's estimated that in about 1 billion years, the luminosity of the sun will be somewhere around 10% higher. As such, the atmosphere on Earth will closely resemble that of a moist greenhouse. Because of the added heat, all the bodies of water on our planet will start to rapidly evaporate. Moving further to 4 billion years from now, the temperature on our planet will soon transform it into a Venus look-alike. It might get so hot that the Earth's surface will begin to melt away.